The next type of system of nonlinear equations that we are going to look at is the intersection of a line and a circle. So we again have three possible scenarios that we could have in this case. We could have the case that the line and the circle do not intersect each other at all, so that they have no point in common and would have no solution to the system. It is possible that the line lies tangent to the circle, meaning that it only hits the circle in one point, and there would only be one solution, the ordered pair xy, where they touch each other. And then finally, it's possible that the line goes through the circle and hits the circle two times, giving us 2 points of solution, x1, y1, and x2, y2. And we'll see which of those cases we land in when we look at our second example. So we again have 4 steps that we are going to follow to work through example 2. So just looking at this example, which of these equations is linear? We can tell a linear equation because both x and y will have an exponent of 1. So we don't see that exponent of 1 there because we don't have to write it. But this second equation here is the linear equation. It's even in the very popular form of y equals mx plus b. And this first equation here is a circle. So let's go through our steps of solving this equation. So step 1, we want to solve the linear equation for one of the variables. It doesn't matter which variable we solve for, but that linear equation of y is equal to 3x minus 5 is already solved for y. So I don't have to do anything to manipulate that equation because we already have y isolated on one side of that equation. Sometimes you may have to move things around, but this was not one of those cases. So now let's move on to step 2. Step 2, I want to substitute the expression that we had from step 1 into the equation for the circle. So the equation for the circle is x squared plus y squared is equal to 5. Equation 1 from the line told us that y was equal to 3x minus 5. So I'm going to substitute in for that y. So instead of x squared plus y squared, I'm going to replace the y and have 3x minus 5 squared. And all of that is still equal to 5. So we replace the y in the circle equation with the expression for y from the linear equation. So now we're on to step 3, where we want to solve for the remaining variable. So in step 3, I'm going to be working with this new equation here that only has x in it, and we're going to solve for x. So let's do some algebra. I'm going to take that 3x minus 5 and square it, which does mean we have to FOIL it out, use the distributive property. You may want to use the box method to do that. But as long as you're using the distributive property, we're in good hands. So I'm going to distribute here. 3x times 3x gives us 9x squared. 3x times negative 5 is a negative 15x. Negative 5 times 3x is another negative 15x. And then negative 5 times negative 5 is a positive 25. And all of that's equal to 5. I'm going to combine like terms on the left side of this equation. We have an x squared and a 9x squared that come together to give us a 10x squared. We have a negative 15x and a negative 15x that come together to give us a negative 30x. And then we have a plus 25, all still equal to 5. This is a quadratic equation because the highest power of x that shows up is 2. And we solve quadratic equations by getting 0 on one side and factoring, if we can, or using the quadratic formula. So to get 0 on one side, I'm going to subtract 5 from both sides of this equation, leaving us with 10x squared minus 30x plus 20 is equal to 0. All 3 terms on the left side of this equation have a 10 in common, so we can factor out a 10, leaving us with x squared minus 3x plus 2 is equal to 0. If the 10 in the front is throwing you off, do note that we can divide both sides of this equation by 10 to cancel that out. So we're really only concerned with where the quadratic of x squared minus 3x plus 2 is equal to 0. This can be factored. Our leading term is x squared, so we know that when we factor it, both of those factors will have an x in them, and we're looking for two numbers that multiply to positive 2 and add up to negative 3, and those numbers are negative 2 and negative 1. We'll now set both of those factors equal to 0 using the zero product property to conclude that x is equal to 2 or x is equal to 1. So it does look so far like we may be in this case here where we have two solutions because we have found two different x values. We will have to check in step 4, but let's finish up step 3 by finding what y is equal to. So we have two possible values for x. We're going to go back up here to this equation for y and use it to figure out, well, what is y equal to when x is equal to 2? And what is y equal to when x is equal to 1? So I'm going to be subbing in here. So when x is equal to 2, I'm going to replace the x in this equation with 2 to get 3 times 2 minus 5 to see that y is equal to 1. So it looks like 2, 1. The x value of 2 and the y value of 1 is a possible solution. And when x is equal to 1, y is equal to 3 times 1 minus 5, which is a negative 2. So it looks like we have the point of 1, negative 2 as another possible solution. Now we have to go on to step 4 and check our solutions in both equations because it is possible that we have an extraneous solution and we cannot use it. So our two equations are x squared plus y squared is equal to 5. And y is equal to 3x minus 5. And we're going to check both solutions. Let's start with the potential solution of 2, 1. So I'm going to substitute in x is 2 and y is 1 and check if that does work in this equation. So 2 squared plus 1 squared is 4 plus 1, which is 5. It does work in the equation for the circle. And let's see if when I plug in x is 2 and y is 1 into the second equation, if we also get something that is true. 1 is equal to 6 minus 5. And so this equation is also true. And so 2, 1 is certainly one of our solutions. That checks out. Now let's check the second potential solution of 1, negative 2. So now I'm going to be substituting in when x is 1 and y is negative 2. Does that really equal 5? Well, that is 1 plus negative 2 squared is a positive 4. That is 5, so that does work out. Let's check it in the linear equation. When x is 1 and y is negative 2, plugging into that equation, we have negative 2. We're checking to see if that's equal to 3 times 1 minus 5. And negative 2 does equal 3 minus 5. And so it works in the second equation as well, which confirms that 1, negative 2 is also a solution. And so we do have two solutions for this system of nonlinear equations. I again want to show you how you can check these solutions Desmos. This does not mean that you could just run to Desmos and plug in these equations and get your solution from there. All of this algebra here is necessary. But when I graph the first equation of x squared plus y squared is equal to 5, I do see a circle centered at the origin with a radius of square root 5. And when I graph the second equation of y is equal to 3x minus 5, we do see a line with a y-intercept of negative 5 and a slope of 3. And the two intersection points where the line meets the circle are in fact the two answers that we have in orange and purple of the points 2, 1 and 1, negative 2. So that confirms what we found algebraically in example 2.